to talk about scalar products. So scalar products, my children, are also called as dot products. Okay, so dot products. Why is it called dot product? It's actually because, as you can see, it uses the symbol A dot B. So that's why it is called dot product. Okay, now there are two definitions of scalar products or dot products. That is this one. This is the first one. And this is the second one, which you actually need to remember for the purposes of your examination. So, this one here, let's try to analyze this. Let's try to analyze the first definition. It says A dot B. Again, this is what are you trying to define? According to this one, A dot B is the length of A times the length of B times the angle, the cosine of the angle between them. Okay? When will you use this one? You use this one if you know the A, you know the B, and you know the angle between them. So let's try to have some example. So let's say that I have this angle, and let's say this is vector A, and this is vector B, and let's say that vector A is equal to 5 cm, and let's say that vector B is equal to 4 cm, and let's say that the angle between them is equal to 60 degrees. So what will be the dot product of vector A dot vector B? Take a look at these are vectors. These two are vectors. What does it say is that you take the length of A times you take the length of B, okay, times the cosine of the angle between them. So the length of A is 5 times the length of B is 4 times cosine of 60 degrees. And the cosine of 60 is 1/2. So that's 20 times 1/2 is equal to 10. So A dot B is equal to 10. What makes this one interesting is that these two are vectors. Vectors, also vectors. If these two vectors, you take the dot product, look at the answer. The answer is not a vector, but the answer is just a scalar. That is the reason why it is called scalar product. Okay? Scalar products because two vectors that when you take the scalar product will give you a scalar, just a number without direction, okay, which is a really wonderful phenomenon. Let's try to have another example. So let's say now that I have this, and let's say that this is 10, and I will extend this a bit. Let's say that is 12 cm, 10 cm, and this is 90 degrees. Okay, so let's take the dot product of these. So A dot B, let's say this is my vector A, and this is my vector B. Okay, A dot B is equal to the length of A is 12, the length of B is 10, times the cosine of 90 degrees. So this is now 120, but then the cosine of 90 is 0, right? 0. So therefore this is 0. So this one is something that you need to remember, guys. If the dot product is equal to 0, it means the two lines are perpendicular with each other. Perpendicular. Perpendicular, or what do we call as orthogonal vectors. So the vectors are perpendicular if the dot product is equal to 0. Please take note of this. It's very important because in your exam, sometimes you're being asked to show that the two vectors are perpendicular with each other. Okay? To show that the two vectors are perpendicular with each other, then you need to take the dot product and make it equal to 0. So before I proceed to the second definition, let's try to look at first some properties. Okay? These properties are important. Okay? So the first property is that the dot product is commutative. Commutative, it is because the vector B dot vector A is the same as A dot vector B. Okay? Why did we say so? Because by definition, what we said, A dot B is equal to the length of the A times the length of the B times the cosine of the angle between them. Well, this definition says the length of the B times the length of the A times the cosine of the angle between them. And as you can see, this left side and this one is equal. So please don't forget, this is an important property that A dot B and B dot A is equal to each other. Okay? So it means that it is commutative. The other one is that it is distributive with each other. Distributive over addition. Distributive over addition. Okay, what does it mean? It means that vector A dot vector B plus vector C is equal to A dot B plus A dot C. Okay? Similarly, if you have B plus C, again, these are vectors, dot with vector A is the same as B dot vector A plus C dot vector A. Okay? This is very helpful when you do and solve some exercises. Now, the other one is this. This is the other definition of the dot product. Why? As you can see, in this definition of the dot product, it is not it does not rely into the length of the A and the length of the B and the angle. It does not, what I call this one, rely in that one. So, when will you use this definition? You use this definition if you do not know the length and you do not know the angle. Then use this one. Okay? Now, how is this being derived? It is being derived in your book. I will just go over with the book, okay? So let's say that you have here a vector triangle. You have your vector A, and then you have your vector B. So you are looking for vector C, for example. And vector C definitely is minus A plus B. Okay? or B minus vector B minus vector A. If your vector A is this and your vector B is this column vector, B minus A will give you this one. And as you can see, if you take the length of C, remember, what did we know? If you take the length or modulus of C, that is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared plus z sub 2 minus z sub 1 squared. And that is actually this part. Okay? If you expand each of them, this one, this is the expansion. This one, this is the expansion. And this one, this is the expansion. If you rearrange it, as you can see, you will notice that, let me just erase this. Upon rearranging, you will notice that you can combine this a1 squared like this, right? I think that's too much. You can combine this a sub 1, a sub 2, this part. Okay, and you can also combine this one, this. Okay, minus 2 times this. All right, now, but then this one here is actually, remember what is this? A1, A2, A3. Remember, if the vector A is equal to A1, A2, A3, then the length of the vector A, the modulus, is equal to A sub 1 squared plus A sub 2 squared plus A sub 3 squared. Okay, that is a formula. Last time, we denote, for example, vector P is equal to xyz, and then we said that the length of that is equal to square root of x squared plus y squared plus z squared. They're the same. They're just the same, right? So that is actually this part, and that is this part. And then this one is actually this part. Okay? Don't get lost, huh? So, as you can see from here, this one is somehow similar to the cosine rule because it says c squared is equal to a squared plus b squared minus 2ab cosine c, cosine of the angle. Meaning to say, my children, this portion here is modulus of a, modulus of b, cosine of theta. That part. So when you compare. So therefore, this one now is the definition. Okay? Guys, I would like you, I told you to remember the 2. I told you to remember the 1. But the one that will really help you is to remember this part. Okay? You need to remember this one. Because this is the key to answer many problems in your examination. In the next video, I'm going to use this one to solve problems. So guys, I will not give examples anymore from the book, but I would rather give examples directly from the past papers. Okay? Watch it out. Thank you.